Assalamu alaikum students. Today we are going to discuss numericals of electricity, unit number 11, National Book Foundation book for physics. The statement of the first numerical is, if 1 ampere current flows through a copper wire having 1 centimeter square area of cross section and 10 kilometers length, calculate the time required by charge carrier to travel from one to other end of the conductor. Free electron density of the copper is 8.5 into 10 raised to power 28 per meter cube. Now, the solution of the numerical is, first we are going to see what are the given values. The first given value is the value of the current, which is 1 ampere. The second given value is area of cross section of the wire, which is 1 centimeter square. We need to convert that 1 centimeter square into meter square. This becomes 10 power minus 4 after the conversion of centi into meter. As we have square on meter, so we need to convert centi into when we convert centi into meter, it becomes 10 power minus 4. Length of the wire is 10 kilometers. Kilo becomes 10 power 3, so the length is 10 into 10 to the power 3 meters. In this numerical, we need to find the value of the time traveled, time taken by the charge carrier to travel this much length of the wire. Delta T is question mark. The value of number density of the electrons of the copper is which is represented by small n. It is 8.5 into 10 to the power 28 per meter cube. Now, as we know that according to the formula of distance, it is S is equal to Vt. For the given case, distance traveled by the charge carriers become the length of the wire, L. S becomes L. V remains V and T is delta T. Now, as delta T is unknown, so we move it to the left side and the formula becomes L by V. As we know that this V is basically the drift velocity of the electrons as these electrons move through the wire. So the formula for the current in terms of drift velocity is given by this. I is equal to NAQ into V, where N is number density, A is area of cross section, Q is charge on a single particle, that is an electron, and V is the drift velocity. Now drift velocity becomes I over NAQ. If we put the value of this V in the relation of T, so this becomes L over I O over NAQ. As NAQ is basically, these terms are basically denominators of a denominator, so we need to move these denominators to the numerator side and the formula becomes this. Okay? Now, as we know that the value of length is given, yes, it is given. The value of small n is given, yes, it is given. The value of A is given, yes, it is given. The value of charge, as it is a universal constant, we need to know the value of Q. It may not be given in the question statement. So as Q is 1.6 into 10 to the power minus 19 coulombs. I is also given, yes, it is given. So by putting the values of all of these given values, we get the required answer, which is in as per the SI unit, it should be in seconds. So we get a required answer. Alright. Now, moving on to the second numerical of the exercise. The statement of the numerical is, calculate the flow of the charges per unit time inside the EMF source having potential of 2 volt and terminals are connected with each other having internal resistance 0.02 ohms. Now, in the given case, we need to find the flow of charge per time. As we know that charge is Q, but flow of charge is represented by delta Q. So delta Q is flow of charge per time is delta Q by T. As we know that delta Q by T is basically current. So we need to find the value of current in the given numerical. So delta Q by T, which means I, is question mark. Now, in the given statement, we have a potential difference given to be 2 volt. Internal resistance of the EMF source is small r. It is given by 0.02 ohms. As we know that by Ohm's law, V is equal to IR. For the given case, we need to find the value of I, which comes out to be delta V by R. Now by putting the two given values V and R, we get the answer comes out to be 100 amperes. So this was the second numerical. I hope so you have understood both of these numericals. In this series we will be solving all the numericals of the given unit. So stay tuned and keep watching the channel and keep watching the solutions. Allah Hafiz. Thank you very much.